Hello and welcome to Vodcast 2.4. In previous Vodcasts, I've overviewed the formation of igneous rock, and I also discussed how mechanical and chemical weathering can produce sediment. In this video, we will discuss the formation and characteristics of sedimentary rock. The picture at center isn't new to you. In our previous Vodcast, we talked specifically about mechanical and chemical weathering, and ultimately, weathering produces small rock fragments. Those rock fragments can fall down hills, get carried through streams or rivers, get blown by the wind. But the point is the sediment grains get transported, and then deposition is when the grains settle, say to the bottom of the ocean floor. The key concept we have to talk about when we talk about the formation of sedimentary rock is lithification. To explain how lithification works, take a look at the picture at the far right. Now the very first sand grains you run into are pretty loosely packed, and they have a lot of space in between the grains. As you go deeper and deeper and deeper into the layers below that top layer, there is a significant increase in pressure and temperature. When I was a kid, we used to play monkey pile, where a large group of kids would basically form a human tower. And the kid at the very bottom of the pile felt a lot more pressure than the kid sitting at the very top of the pile. It's the exact same concept when we talk about the sediment shown in this image. At a certain point, lithification will begin, and that is the birth of sedimentary rock. There are two primary ways in which sediment can be transformed into sedimentary rock. The first is compaction, and that's when the sediment grains get pressed closer and closer together so that the pore space in between them is reduced significantly. Compaction is most significant for your fine grain rocks, for instance siltstone. The other process by which sediment is transformed into sedimentary rock is cementation, and that occurs when water containing dissolved minerals moves through pore spaces in sediment. Those dissolved minerals can recrystallize, and they can act just as cement would act for our folks knowledgeable in construction. Cementation is significant in coarse grain rocks, for instance conglomerate. If we take a look at my rock cycle image, which we've looked at in every previous podcast, the purple arrow that allows us to go from sediment to sedimentary rock is lithification. And that sediment is very often produced by the chemical and mechanical weathering of igneous rock. When those little weathered rock fragments get transported and deposited, we see that the accumulation of sediment will ultimately lead to the formation of sedimentary rock. A good working definition for sedimentary rock is that it's rock that forms after weathering breaks rocks down, gravity and erosional agents transport and deposit the sediment, and the sediment becomes lithified. I overviewed that process a little bit on the last slide, but this definition in words may be helpful as well. Another very important point to keep in mind is that sedimentary rock may contain fossils. You will never find fossils in igneous rock, because remember, igneous rock forms from the cooling of magma and lava, and magma and lava are so hot that they would incinerate any plants or animals that may have fallen into the magma or lava. In my possession, I have what's known as fossil limestone. Limestone is a very, very common sedimentary rock, and if you take a look, you can maybe see the shell inside of this limestone sample. Speaking of fossils, let's talk about fossil fuels, specifically coal. Coal can be defined as a sedimentary rock, and it's ultimately composed of plant and animal fragments. There are two main types of sedimentary rock that we're going to talk about in this podcast. The first being detrital sedimentary rocks. Detrital sedimentary rocks form from solid particles weathered from other rocks. So these rocks may contain the weathered remains of igneous rocks, for example. Detrital sedimentary rocks can be classified based on their particle size. As an example of a coarse-grained detrital sedimentary rock, we can take a look at conglomerate. I have a sample of conglomerate right here, and you can see some really good cementation that's gone on in this sedimentary rock. At the other end of the spectrum, we have very fine particle size. The constituent particles here are predominantly of clay size, and shale is an excellent example to consider. Here's a sample of shale. And what's interesting about shale is that it's actually one of the major issues we're dealing with when we talk about fracking. Shale is very rich in natural gas, and although I don't want this video to run 15 minutes, I will simply say that fracking is the drilling and cracking of shale rock to release that natural gas, with some potentially bad consequences attached. The other type of sedimentary rock that I'd like to overview is chemical sedimentary rock. The formation of chemical sedimentary rock relies primarily on water-carrying ions, and then when that water evaporates away, solid material will precipitate to form chemical sediments. As an example, if there's a region of salt water and all the water evaporates away, what you're left with is rock salt. And here's a piece of rock salt. It's kind of cool looking. Rock salt is a crystalline and granular aggregate of sodium chloride deposited from evaporating seawaters. Another really important sedimentary rock that I want to overview is limestone. By now you realize that granite is my go-to igneous rock, while limestone is my go-to sedimentary rock. We have a lot of limestone here in the Midwest. There are limestone quarries spread just about all across the state, and about 90% of limestone is formed by organisms. Here's a piece of limestone to take a look at. Limestone consists primarily of calcium carbonate, and the materials necessary for the formation of limestone are mainly precipitated by marine organisms. Okay, that concludes our video podcast regarding sedimentary rocks. Hopefully our rock cycle image is starting to make some sense. And in our final vodcast, we will talk about metamorphism and metamorphic rock, the last stages necessary for us to complete the cycle.